differentiation is what we have been looking at since a couple of days now, and today we want to look at trigonometric function derivative. Now, under trigonometric function derivative, we can have a sine function and we can have a cos function or tan function. Now, if we have a function of sine ratio, that is y sine f of x, if y is sine f of x, then dy dx is going to be equal to f prime of x cos f of x. And also, if y is equal to cos f of x, then dy dx will be equal to minus f prime of x sine f of x. Similarly, if y is equal to tan f of x, dy dx will be equal to f prime of x sec square f of x. So that is the summary of the trigonometric function derivative, and we're going to apply them one by one for clarity. Now, examples. Let's take example 1. If we have y, if y now is equal to sine x, if y is equal to sine x, now comparing this function with the formula for sine function. In sine function, we have that y is equal to sine f of x, and the derivative will be f prime of x cos of f of x. Automatically, we can easily say that this x here is the f of x in comparison with the formula, so that is x. Therefore, f prime of x therefore will be that derivative of function of x. That's the meaning of f prime of x, or dy dx. That will be 1. Now, introducing this into the formula, in the formula we have that dy dx will equal to f prime of x cos f of x, that derivative of y equal to sine x, because x there is f prime of x, so dy dx automatically will be equal to f prime of x, which is 1, times f of x cos f of x, which is cos x. So that gives us what? Cos x. So whenever we differentiate sine x, we have cos x, but this is the formula to be used. Now, having said that, let's move on to cos function. If we are now handling cos x instead of sine x, y equals to cos x, we can easily say that our function of x also is x here. That is, this one is the function of x, and f prime of x is derivative of function of x, which is also 1. But when y is equal to sine x, cos x, dy dx will be equal to minus f prime of x sine f of x. The formula is already stated there, so that's what we have here for the formula. Now, that is our f prime of x is 1, so that's minus 1 times sine f of x, which is x, so that's minus sine x. So that derivative of cos x. If y is equal to cos x, then derivative will be minus sine x. Now we can move further to third example, which has to do with tan function. If y is equal to tan x, of course we know that our function of x in this case is x, so f prime of x is going to be 1 as well. Now, putting that into the formula for tan x, you know that dy dx will be f prime of x, which is 1, times sec square f of x, and that is sec square. Our f of x is x, so sec square x, that is what? Sec square x. So dy dx of tan x is equal to sec square x, sec square x. Alright, that's example 3. Now, having done that, we can go ahead to solve more problems as time permits us. Now, number 4, we have y be equal to half sine 4x squared. Now, this is a constant. This is a function of x. Now, we are going to multiply the constant by whatever we get upon differentiating the sine 4x squared. Now note that f of x here is equal to 4x squared, right? So f prime of x will definitely be 8x. We'll differentiate this, we get 8x. So the y dx now we equal to half times the differentiation of this, which is f prime of x, which is 8x, and cos f of x, which is cos x squared. So that gives us half times 8, that's 4x cos 4x squared. Please know that this half does not affect the 4x squared inside here, it only affects the coefficient of the cos function. So please take good note of that. That differential function of the function that we have here. Now we can go ahead to another example. I think we have like 6 examples here. We have tackled 4 now, remaining 2. So number 5, we have y to be equal to cos 4x squared plus 5x. Now immediately we know that f of x is equal to 4x squared plus 5x. So f prime of x there is going to be equal to 8x plus 5. Automatically the y dx will be, since it's a cos function, will be minus f prime of x. So that's minus 8x plus 5 into sine function of x. That's sine 4x squared plus 5x. So that's the derivative of the cos function. If we have this, we know that the derivative of cos function is minus f prime of x sine f of x, and these are f prime of x, so minus, because it's a compound expression, we have to introduce the brackets so as to make it easier. We can expand it and we can leave it like that. So that's the answer for that. And the last example that we're going to take today is y equals to 1/3 of tan x to the power 3. Now again we know that our f of x is equal to x cubed, the f prime of x will be 3x squared. So the y, the x will be f prime of x, which is 3x squared, sec squared. Now 1/3 there is multiplying that derivative, please. 3x squared sec squared function of x, which is x cubed. So we have 3 cancel 3, so we are left with x squared sec squared x cubed. Take good note of that this constant, we only multiply the derivative of the function. So we don't use this 1/3 to multiply the x cubed of the sec function. Thank you very much. I wish you all the best.